All right, so welcome back to the OneClass stream. Again, my name is Joey. I'm going to be your math teacher for this session. So what we're going to do today is we're going to look at probably questions predominantly in Algebra 1, Algebra 2, and also in pre-calculus as well. So these are kind of our questions that we're focusing on for today. For the next hour, I have about 11 questions that we can go over. Again, if you're tuning in for the first time, thank you so much for watching. What we're doing here is that we are working towards verifying solutions in high school subjects such as in math and in chemistry, particularly in the secondary school level, and also in the college and the university level as well. Again, my name is Joey. I am currently a secondary school educator in Ontario, and my teachable subjects are chemistry, and I'm currently working towards my math teachable as well. So let's get started for these questions for today. So let me load those up for you. So my first question here says that find the numbers at which f is discontinuous. At which of these numbers is f continuous from the right or from the left or either? So let me just I don't know if I can download these guys here. Let me just see if I can download both these images here and open those up for you. See if I got it. Okay, so this is the question here. It says find the numbers at which f is discontinuous. At which of these numbers is f continuous? F is continuous from the right or from the left or neither. So let me just write this down first. This is question 1 here. I'm given this f of x here, or some function. This is going to equal, basically we know it's a piecewise function, right? So it's x plus 1 if x is less than or equal to 1. It's 1 over x if x is between 1 and 3. And then finally it'd be square root x minus 3 if x is greater or equal to 3. So we have these three. We have a piecewise function here. It's asking us if f is find the numbers at which f is discontinuous. At which of these numbers is f continuous from the right or from the left or neither? So basically, what we see here is we're going to look and break this down into 3 parts. We're going to break this down into 3 functions. So our first function, our second function, and our third function. So our first function here says that x plus 1, or f of x equals, our function f of x equals x plus 1 if x is less than or equal to 1. So therefore, when we're checking for discontinuous and continuous points, what we're going to do is we're going to sub in 1 here. And we'll sub in 1 here for this equation as well, because the numbers we care about are basically the points in which it could be continuous or discontinuous. So we care about this 1 value here. We care about this 3 value as well. So we're going to basically check for 2 points here. So if I'm subbing in f at 1 here, I can say f of 1. This here is going to equal 1 plus 1. So f of 1 here would be 2, right? F of 1 here would equal 2. And then finally, I could also check in to prove that if it's continuous or discontinuous, I can plug in f of 1 for the second function here, because it's stating if the function is 1 over x if it's between 1 and 3, right? So I'm going to see if it's actually approaching this point here, which is 1 and 2. So I'm going to do this in black here. No, this is my second function is 1 over x if it's between 1 and 3 here, right? So plug in f of 1 here equals 1 over 1, which is f of 1 here equals 1. So as you can see here, both these guys here, f of 1 and f of 2 here, these guys here are different points. I have a point here which is 2 and 1, and I have a point here which is 1 and 1. So therefore, this the point here, sorry, this is 2, this is 1, 2, sorry, this here is 1, 1. So therefore, because these 2 points are not the same, therefore, when x equals 1, it is going to be a discontinuous function. So basically discontinuous, or I can say if x equals 1, it is discontinuous. If it was a continuous, both of these points would be the same point, so they would connect evenly, but in this case, it's a discontinuous function. So finally, we checked for f of 1. Now we have to check for f at 3 here. So we're going to use basically equations 2 and 3 to figure out if it is a continuous point. So I'm going to use equation 2 again, because it's f of x equals 1 over x if it's 1 between 1 and 3. I'm going to put f of 3 here. It's going to equal 1 over 3. So this is here is my first point. And then finally, I'm going to check for 3 here if it was the third function here, because it's going to actually exist at x equals 3 here. So the point that it's actually going to exist. So it's f of x would equal, I think it's square root x minus 3. X minus 3 if x is greater or equal to 3. I'm putting in f of 3 here equals 3 minus 3, which equals root 1, which equals 1. So f of 3 here equals 1. So therefore, my terms here, my points here, I have 3 and 1/3, and I have 3 and 1 here, right? So as you can see, both of these guys here are indeed discontinuous here. So again, I have both points here. As you can see, they don't match up. So therefore, I can say that at x equals 3, this point is also discontinuous. So at x equals 3, it is also discontinuous. So therefore, I can say that if x equals 1 or 3, both points are discontinuous. So the answer is saying find the numbers here. So where f is discontinuous, as you can see here, they plugged in the 1 and 3 into their piecewise functions, and as you can see, f of x is fully continuous between 1 and 3. However, it is discontinuous between at 1 and 3. There are discontinuous points, right? So therefore, we basically at every other point besides 1 and 3 here, the function here is continuous. So you can say that the solution is correct. Solution is correct. They didn't really show the mathematics behind this like I did, but it's fine if because they described it as well. Solution is correct. Great analysis. You can also say that at x equals 1, 1 and 3, at these points, f of x is discontinuous. Discontinuous, and you can say, I think I misspelled discontinuous. At other points in the function is continuous. So I'm going to add that, and this solution here is correct. So great first question, great calculus question here. So it's question 1. Can look at question 2 here. It's asking how many solutions do the linear equations have. So I have here y equals 2x minus 5, and I have this here 8x minus 4y equals negative 20. So think about this problem here, and we're talking about how many solutions do this linear equations have. So how will we figure out this systems of SLE, systems of linear equations? What we have to do is we have to put it into the same form, right? We're going to put it into the same y-intercept form. Or you can use substitution or elimination to figure out the solution here. So for in this case, I would probably use substitution, but you could use elimination as well, depending on what you're more comfortable with. I'm personally more comfortable with substitution, so I'll do that. But the solution here might use elimination as well. So take a moment to think about this. I have basically, I'm going to say this is equation 1, and this here is equation 2, and I have to figure out how would I use substitution here to figure out my a variable first. So remember I have two equations, I have two unknowns, which means I can use this substitution or elimination to eliminate a variable first, and then I can solve for my one variable. So take a moment to think about this problem, and we'll take it up in a minute. So let's use, in this case I said I'm going to use substitution, right? So I'm going to basically sub 1 into equation 2. I'm substituting equation 1 into equation 2. So again, why I choose 1 instead of 2 is because in equation 1 here, I'm already isolating from my y. My y is already left alone here. I don't have to use algebra to manipulate this equation for me to isolate for something. So basically, I'm going to sub 1 y into 2 here. So which means I'm going to get basically equation 2 is going to look like this. It's going to get negative 8x minus 4. And my y here is now 2x minus 5, right? I'm going to substitute y 1 into 2. So I'm going to have 2x minus 5 here. And this equation is going to equal negative 20. As you can see here, 2x minus 5 here derives from this, it comes from this first equation here. And all I have to do here is now solve for x, right? I can do distributive property to expand the brackets here. So I have negative 8x minus, again, 8x again, minus 4 times negative 20 is positive 20 equals negative 20. Negative 8x minus 8x here would be negative 16x plus 20 equals negative 20. And then what I can do is negative 16x plus 20, I can move 20 to the other side. I can say that negative 16x equals negative 20 minus 20 here would equal 40, right? So minus 20 minus 20 minus 20 is 40. And then finally, x here would equal basically 40 over 16, over negative 16, right? Or negative 40 equal over 16, which will basically, if I reduce this to lowest terms, this would be, let's see, I can divide both by 8 here. I would get 5 over 2. So this here is x equals negative 5 over 2. And then what we can do is we can substitute this x value for any of these equations here. So negative 5 over 2, I can substitute it into my first equation. So I can sub x equals negative 5 over 2 into 1. And I can say that y here equals 2 times negative 5 over 2 minus 5. So now I'm solving for y here. Y is now 2 times negative 5 over 2 here would be simply negative 10 over 2 minus 5. Y here, this here simplifies to negative 5 minus 5. This here, y here equals negative 10. So this here is my point of intersection. You can say that this systems of linear equations, SLE, has one solution. And it is in the points negative 5 over 2 and negative 10. And this here is my solution for this problem. And let's see what they did here. So it says we have a simple sisters of linear equations, which is good, which is further simplified. So they can check for systems of linear equations. Now in our problem, we have 2, negative 1, and negative 5. Okay, so they're actually rewriting this as a matrix, or as a matrix here, and they're trying to solve, and basically they're using systems of linear equations to basically solve for if it has one solution, a unique solution. So like I had here, no solution or infinite many solutions as well. In this case, they wrote here they have a systems which has a unique solution, and I actually went a step further and I solved for the systems of linear equations. So this here has one solution, and which is the exact same thing as unique solution. And I think this question was also just asking how many solutions. So I think the solution is fine. So the solution is correct. Good analysis here. And basically it's a topic of, you can think of this as a grade 10 problem where we're talking about the point of intersection between two linear lines, or you can think about this as a linear algebra problem when we're talking about systems of linear equations. We could rewrite this as a 2x2 matrix and then basically solve for the matrix here to basically solve for x and our values to solve for whether or not it has indeed basically one solution, no solutions, or infinite amount of solutions. Again, depending on what this means here, if I show you visually, if I have 2 points here, they can basically be parallel lines. So again, I have no solution in this case. They can intersect at some specific point here, which means it has one solution, or you can say unique solution. And finally, it could be an infinite solutions if both lines directly overlap each other, right? If both lines are the exact same lines here, this will have an infinite solutions here because they're all the same lines. In this case here, no solutions here is an inconsistent, and both these guys here are consistent. So don't worry about, if you don't know those terms, these are kind of, this here is introduction to linear algebra, so don't worry about that. But we can also just think of this as a grade 10 problem here. So say solution is correct, good analysis here. And basically we're just finding the point of intersection for two lines. You could think of this as that concept as well. Okay, that was number 2. Number 3 is asking unit circle. So maybe what is a unit circle? The question is kind of broad here, so I don't really know what the question is asking. Or maybe I'll just define what is a unit circle. So I'm gonna draw out my plane here, and then I'm gonna draw out a circle. Okay. So this is a unit circle, and basically, again, we know that this here is x, this here is y, and basically, for a circle here, we obviously have a center of a circle. In this case, I put 0, 0, and in the diagram they put 0, 0 as well. But basically, an equation of the circle looks something like this. You can think of it as x minus some r squared plus y minus some s squared equals r squared. So this here is the equation of my equation of a circle. And what does this mean? So equation of circle. Basically, this means that I have both an x and a y value, right? As you can see here, for a unit circle in itself, it would be specifically x squared plus y squared equals 1, right? Or 1 squared. And this point here would be basically 1, 0. This here is 0, 0, and this point would be 0, 1 here. So this here is our unit circle. What this means is that we have an x-intercept, or you can say we have 2 x-intercepts. One is 1, and one here is -1. We have we have 2 y-intercepts here, which is 0 and 1, and 0 and -1. So this here would make up the circles here. For x squared plus y squared equals 1, and then and 1 here is the radius, right? So my radius of my circle here equals r, right? And this here, in this case, r here equals 1. So, because I know it's 1, 1, and yeah, this here is 1 here. So this here is the radius of my circle. So r here is radius. This actually, I'm gonna use I won't use r in this case actually, because it's kind of confusing. If I use r, maybe I'll use t here or something like that. T here, or I think it's actually s and t. The correct symbols, so s and t, where this s and t are basically points that are in the center of the circle. So this determines the x and y values for center of circle. So in this case, because it's 0, 0, then I simply just have x squared plus y squared equals 1, right? So in this case, s and t are 0. Both of these variables are 0, but that's not, that's only specific for the unit circle. If my center of the circle was another point here, I would have an s and t value as well. So this is basically a unit circle. You basically learn this when we talk about quadratic functions here, because we have one quadratic function here and another quadratic function here. And basically, a lot of the questions you would have to complete the circle to find the center of the circle, or to find what the radius is of the circle. So I'm going to say solution here is correct. Good analysis as well. Okay, that's number 3. Number 4 is asking, what is the derivative of cosecant? Is that cosecant x? Well, I don't know what this I believe they want to say cosecant, but I think they spelled it incorrectly they notated it different incorrectly here. So let me just write down number 4 here, because cosecant x is CSCX, so not COSCEX. So say, what is the derivative of it's cosecant x, not cosecant x spelled like this. This here is wrong. It's CSCX here. Okay, so how do you figure out cosecant x? Well, what we're gonna have to do is here is a reciprocal derivative here, or sorry, reciprocal trigonometric ratio, right? Cosecant x, we know that here cosecant x also equals 1 over sine x, right? So you can say that if f of x here equals cosecant x, you can rewrite f of x here as 1 over sine x, right? We know that cosecant x is simply just 1 over sine x from our reciprocal trigonometric ratios. And we can also rewrite f of x here. If we know that's 1 over sine x, we can rewrite this as simply sine x to the power of -1, right? So given this, what we're going to do is we're going to find the derivative, right? So in order for us to find the derivative here, we're going to set this is now f prime of x. We're going to find the derivative of f of x. So we have f prime of x equals, I'm going to bring this negative sign down, or -1 here down. That's my derivative rule. I'm allowed to do that. I have -1 here times whatever is on the inside, which is sine x here, times the chain. We're going to use chain rule here, and we're multiplying by what is inside the derivative, or what is this here. Well, what we have here is sine x, right? So what's the derivative of sine x? We all know that this here is cos x here. So this here is our kind of derivative for for cosecant x here. So we have negative sine -1 times we have -1 times sine x, and what we're gonna have to do is we're gonna have to lower the exponent as well, right? So it's -1 minus 1, so obviously -2, and then we are gonna multiply it by whatever the derivative of the inside is, which is cos x here. Derivative of sine x is cos x. Fluorescent says, I love you for doing this. Well, thank you so much for tuning in, by the way. So that's what we have here. And what we can do is we can simplify this, right? We can say that we have -1 times cosine x, or we can simply just say negative cosine x. And we can simplify sine x to -2 here by simply just putting sine x squared like that. Because sine x to the power of -2 is simply just the reciprocal, is simply just 1 over sine squared x, right? So this here is our derivative for cosine x, or cosecant x. I think I'm writing on a slant here, which is kind of odd. I think I shifted my tablet differently. Sorry about that. It's kind of bothering me now. But I can simplify this even further, right? I can say that this is negative cos x over sine squared x, right? Let me just rewrite this here. And I can rewrite this, right? I can rewrite this as simply, this here is negative cos x. I can rewrite this as sine x times sine x, right? So sine x times sine x. And we know that here we have cosine over sine x. This is simply just cotangent, right? This here, cosine over sine here is cotangent, right? We know sine over cosine is tangent, so therefore cosine over sine is cotangent. So let me just write that down for you. So tan x equals sine x over cos x. So cotangent x would be simply just flipped, right? It would be cos x over sine x here. So this here would be negative cotangent x. Remember, I still have the negative here. Times, I have now simply just 1 in my numerator, 1 over sine x, which is simply just negative cotangent times negative cotangent x times sine, or cosecant x here. Cosecant x. And this here is our derivative for cosecant x here. So negative cotangent x times cosecant x. And as you can see, we got the correct answer as well. They did cosecant x times cotangent x, same thing, or negative cosecant x times cotangent x. This here is also the correct solution as well. What they did with their explanation is that they actually did a u substitution. So basically they did something that's they could do that as well, but I didn't do that personally. So they basically said let u equal sine x here. And then they would have, you're taking the derivative in respect to u. So you have u times the -1. So you're going to have f prime of u. So basically you get -1 times u to the power of -2 times the derivative of u here. And basically, and you sub u back into the equation here, and you would get exactly the same. So I skipped that step, which is totally fine, but this solution here is also correct as well. So this solution is correct. They analyzed it pretty well with the u substitution. I didn't do a u substitution personally, but this here works as well. So I'm going to say solution here is correct. Good analysis. So basically, it's just simply a chain rule within a derivative of a trigonometric ratio or a trigonometric function here. So very, very easy. Let's do number 5. It's asking when 2 consecutive negative integers are multiplied, the product is 600. Find the smallest of the 2 numbers. So I'm going to write this down. 2 consecutive negative integers are multiplied, their product is 600, and then it's asking find the smallest 2 numbers. Okay, So what we have here is we have to basically, we're going to have to write some statements here. We're going to have to write some variables here. So it says when two consecutive negative integers. So when we talk about consecutive negative integers, what do we mean by that? We have to say that let negative x be first number, first unknown here. Or say I'll just say first integer, because I have here my first guy here is the first integer, right? I have two consecutive negative integers, which means I have one of them has to be negative x, and the other one has to be, I can have to say negative x plus 1, right? Because it's consecutive. It's right beside that number. For example, if it was negative 3, the next consecutive integer of negative 3 would be negative 2, right? It's simply just negative x plus 1. So let negative x be, this would be the second integer. So we have these two, and basically when two consecutive negative integers are multiplied, their product is 600. So we're going to multiply these two guys here, and we're going to set the equation to 600. So we're going to say negative x multiplied by negative x plus 1 would equal 600. So this here is my equation for this. And as you can see, this here is also correct. What I can do now is I can simply use distributive property. So negative x times negative x becomes positive x squared, so x squared. And then negative x times 1 here is negative x equals 600. What you could do now is you could use common factoring. I have, again, x on x here is a common term. So I have x here, I can factor out x, and then I'll get a negative 1 equals 600. Actually, what I'll probably do is maybe I'll just I won't common factor first, but what I'm going to do is bring 600 to the other side, because I realize I have a quadratic kind of function here. So I'm going to bring 600 to the other side. So I have this kind of function here. And basically, I could try to factor this guy here. I don't know if actually it's factorable. Might be factorable. Let me just think about this here. I'm basically thinking about a product of A and C. So product of 1 and negative 600 would be negative 600 has to sum to negative 1. So let me think about the two numbers that could possibly fit this criteria, two factors of 600. Let me use my calculator. Let's see, 600, I have 60 and 10 would give me 600, but that's too far off. Maybe 300, no, I would have, what about 90? Would 90 be of help? Nope, not really. So if I can't factor this, what I'm gonna have to do is resort to a quadratic formula. So I don't know if this is factorable. Let me see. Can I divide by 25? 25 actually gives me a factor here, so this is actually good. So I can actually factor this. I found out that 600 is actually divisible by 25. So my factors I'm going to use are 25, negative 25, and 24 here, and it's going to add to negative 1. So I'm going to say x squared here equals, I didn't want to do quadratic formula, that's why I wanted to factor this. I'm going to say here it's negative 25x plus 24x minus 600 here equals 0. And then I can say here that I can common factor these two sides, right? I can common factor these first two parts and then these two second parts here. So common factoring this, I would get x minus 25, and then plus I would factor out the 24 here, and I would get x. I would believe this is also negative 25. 600 divided by 24 is 25. But do I should get a positive number, a negative number here. Yeah, so it's negative 25 equals 0. So therefore, I have two solutions here. I have x plus 24 and x minus 25 equals 0. So this here are my two factors of this quadratic function here. So let me erase this because it's kind of messy here. And then what I can do now is I can set both of these guys to 0, right? So I'm going to have two solutions here. I'm going to have x plus 24 equals 0 and x minus 25 equals 0. I'm going to solve this left one first. So move 24 to the other side, which makes negative 24. And then x here, I'm going to move 25 to the other side, which means I would get positive 25. So x equals negative 24 and x equals 25 are my answers. However, one of these solutions are wrong, right? Let's go back to our our problem here. It says when two consecutive negative integers are multiplied, their product is 600. In this case, I have this here is not a negative number, and I only care about the negative number here, right? So in this case, this here is a wrong answer. So this here, I can reject this answer, and I can simply say that x equals 24 is my correct answer. And I can also say that my two numbers here, so x here will have to be 24. So that's I said that let that be the first number, and I said let x plus 1 be my second number, right? So in this case, I would simply write x plus 1 here would be, x minus 1 would be the next number. So this here would equal negative 25, right? So x1 and this here with x2. So these two are my numbers. As you can see, negative 24 times negative 25 will make up 600. So therefore, the solution is correct. This solution here is correct. Again, two consecutive numbers are negative 25 and negative 24. So this here is our correct solution. So they did quadratic formula. I really didn't want to do quadratic formula for the sake of time, so I simply just factored this out, and I realized that 600 is divisible by 25 here. So solution is correct. Good analysis here. And so that was number 5. Let's look at number 6. So asking find another point of intersection question here. Again, we can use substitution or elimination, right? So number 6 is asking I'm going to use the term POI for point of intersection. So I have x plus 2y equals 3, and then 5x plus 4y equals 8. In this case, because it's set up like this, I would probably use elimination, just because the x's are already on one side, the y's are already on one side, and the numbers here on one side as well. So in order for me to eliminate this problem, I have to basically pick a variable and to eliminate. So in this case, you could pick x or y. In this case, I would probably pick, I'm going to write imaginary one here. I would just pick x here just for the sake of consistency. So how I would eliminate this is I would have to basically subtract both of these guys here. And I want to eliminate x, right? So if I want to eliminate x here, I'm going to have to multiply this entire first equation. Let me just label these first equation here. So this is the first equation. This here's the second equation. Actually, let me label this further back here. Here's number 1. Here's number 2. So I'm going to have to basically multiply some type of constant to this first equation for me to get 5 here. I want 1 to be equal to 5, so I'm going to multiply everything by 5 here. So I'm going to get these new values, right? I'm going to get here, this would be 5. 2 times 5 would be 10. And then 3 times 5 here would be 15, right? So I multiplied everything by 5. I didn't change, if you think about it, I didn't actually change the equation. I only multiplied by a constant value, and I can do that. I can do that to this equation because this is still the same line as x plus 2y. X plus 2y equals 3, right? So in order for me, so once I multiply this by 5, I'm not changing the equation. I'm changing the equation by multiplying by a constant number, but it actually doesn't change the equation of the line. So if I do elimination here, I'm going to subtract both of these guys here. As you can see, 5x minus 5x would give me 0x. So these cancel out. So again, I have two equations. I have two variables. I need to eliminate one variable for me to solve, right? So now I have only one variable left. I have y, right? So I have 10 minus 4y is 6y here, and equals 15 minus 8 here would equal 7, I believe. And then y here would equal, I can divide both sides by 6 here, so 7 over 6 here is my y value. And what I can do with my y value is I can plug this y value into any of these equations. So I'm going to plug this y value into equation 2. So I'll say sub y equals 7 over 6 into equation 2. And then I will have negative 5x plus 4 times 7 over 6 equals 8, right? Because again, this y value here is 7 over 6, and this here is, I don't think I have a negative here. I think it's just 5. This tricked me because this is the elimination. So let me put that in brackets here. So this here is just 5x plus 4y equals 8. So I have 5x plus 4 times y equals 8, and I can solve this equation and just isolate for x here, right? So I have 5x plus 4 times 7 here is 28 over 6. Oops, sorry. 28 over 6 equals 8. And then it's 4 times 7, 28. Just checking. 5x equals 8 minus 28 over 6. Again, you can common factor here, and you can make both of them, you can use the lowest common denominator here, right? So I'm going to have to multiply here, this number by 6 here. So I would get 20 over 6, right? 5x equals 20 over 6. And then I can simply divide both sides by 5, right? So if x equals 20 over 6 divided by 5, which is simply, so I can write this as multiplying by 1 over 5 here, right? So 20 over 6 divided by 5 would be 2/3, right? So be here, this is 2/3. Okay, 20 over 6, again, I can reduce these two terms to, again, 10 over 3. And I'm simply just multiplying by 1 over 5 here. And this would equal 10 over 15, which equals 2/3. So x value here equals 2/3. My y value was 7 over 6. So therefore, my point of intersection would be, my x value was 2/3 and my y value was 7 over 6. So this here is my point of intersection for these two lines here. So again, one unique solution here. So it's 2/3 and 7 over 6 here is my answer. And as you can see, this solution here is correct. 2/3 over 7, 6. 2/3 is the x value, 7 over 6 is the y value. This solution here is correct. And they use substitution instead. I used elimination. It doesn't really matter. In this case, I'll use elimination just because it was already both in standard form. So it's a lot easier to do elimination. So solution is correct. Good analysis. I used elimination instead of substitution to answer the problem because both equations were already in standard form. So the solution here is correct. Let's look at number 7. I feel like I'm writing in like a curve. I feel like some viewers might find that kind of disturbing. I don't know why. I think maybe I naturally just shift to the right here. I don't know why. So that number 7 is asking, Michaela placed a frame around a print that measures 10 by 10 inches. The area of just the frame itself is 69 square inches. What is the width of the frame? Okay, so I know that this here is a is the print, right? So I can say here is a square. So let me draw this out. I know the area of the print measures 10 by 10. So this here is 10 by 10 here. Or actually, let me write this inside. It says 10 by 10. And then I'm putting a frame around the print, right? So, and then the area of just the frame itself is 69 square inches. Okay. So I'm putting, let me do this in another color actually. Then this here is the frame around the print, right? I think I should have used actually a line tool. So let me just use a line tool just to make it kind of nicer here. So I have, no, that's a rectangle. I hope this is a square. Kind of. So this here is my 10 by 10 kind of guy, and then I have a frame here. It's basically going to frame. This here is definitely not perfect. So maybe. Okay, so it looks a little bit nicer. Again, it's not even, but it's fine for the purposes of this this exercise here. So again, we have 10. It's a 10 by 10. This is a 10 by 10 frame, and the area of just the frame itself is 69 square inches. So what is the width of the frame? So we know that the area. So what they did here was they solved for the area, which is good. So they solved for the area of the print here. So area is simply just length times W. In this case, it's just 10 times 10. So I have 100 square inches. So this is just the area of the print here. So it's 100 square inches. And then what we can do is they actually drew a diagram as well. So they wrote 10 inches all the way around. And this here, we don't know, right? This here is X, right? So this here is we're trying to find this value here. And this here is x. This here is also x. We have x again. And this here is x. So, sorry. So, as you can see, they drew actually a really, really nice diagram here. And they're basically saying that this entire portion here is 10 plus 2x, right? Because if you think about it, I'll do this in red here. From here to here, this would have to be encompassing this area 10 plus this x here and this x here, right? So in this case, you would have 10 plus 2x on this side, and this is also 10 plus 2x on this side as well. So what we can do is, once we found the algebraic expression for this would be the total area, what we can do is we can write down an equation, right? We can say that the area, or the AT, or the total area, would have to be 10 plus 2x times 10 plus 2 times x here. And this will give us our area of the total frame, right? And as you can see, the area of the frame is 69 inches by itself, and we know that the area of the print is 69, right? So we can basically add up the total area. We can say is the area of the print plus the area of the frame, right? Area of the print here is 100 square inches. The area of the frame is 69, right? So this is 69, which is the total area here would be 169 square inches. And basically, we can sub that in to our equation here, right? So we know that this area total is going to equal 169. And now what we can do is we can use FOIL, and we can use FOIL to kind of break up these brackets. So we get an equation, right? So we have 10 times 10 here is 100. So we're doing this first. We're doing it first. We're doing outside next. 10 times 2x is 20x. We're doing inside here, 2x plus times 10 here is, again, 20x. And then 2x times 2x here is 4x squared. That's the last here. We can collect some like terms. 20 plus 20 is 40x plus 4x squared. What we can now do is we can isolate for our x value, right? So what we can do, or we can simply just we can do this in many ways. We can try to use quadratic formula, but I'm going to see if we can actually common factor this out. So I'm going to move 100 to this side here. So subtracting both sides by 100 would give me 69 equals 40x plus 4x squared here. And then I would actually have to move this back to the other side. So I don't think I can common factor, unfortunately. So I'm going to say 0 here equals 40x plus 4x squared minus 69, or I can say 0 equals 4x squared plus 40x minus 69. And I believe you're going to have to use quadratic formula to figure this out. I don't think this is factorable. Let me see. Let me just check real quick if this is factorable. 440 negative 69. Oh, it is factorable, but it will give us a fraction here. So as you can see, they also did quadratic formula. So let me just do the quadratic formula real quick. As you can see, our solution here is correct so far, right? 4x squared plus 40x minus 69 is correct. So I'm simply just going to use quadratic formula to figure this out. So I'm going to say x here would equal negative b plus or minus, this is b squared minus 4ac all over 2a. So here is our quadratic formula. This here is negative b, which is here is 40. Negative b is negative 40 here. Plus or minus negative 40 plus or minus b squared here is 40 squared, which is 1600, minus 4 times a, which is 4, times negative 69. So this here is extended here. All over 2 times 4 here is simply just 8, right? So this here is negative 40 plus or minus, and then 4 times 4 here. So sorry, I'm going to write 1600 here. 4 times 4 times negative 69. So 4 times 4 times negative 69 is going to give me positive or minus 1,104, or I can simply say plus 1,104 here, all over 8. This here is going to equal negative 40 plus or minus, I don't know why my Siri keeps going off, sorry. 1600 plus 1600 plus 1104 will give me the square root of 2704 all over 8. And then I can plug this into my calculator. Square root of 2704 is 52. Oh, nice. Perfect square here. Plus or minus 52 all over 8. And now I can break this down, right? I can break down x1 here is negative 40 plus 52 all over 8. And x2 is equal negative 40 minus 52 all over 8 here, right? So again, I'm just breaking up this plus or minus part for you as well. And if I solve this, solve for x1 here, negative 40 plus 52 would give me 12 over 8, which is simply just 3 over 2, right? 3 over 2 here. Could divide both sides by 4, or numerator denominator by 4, get 3 over 2. X2 here, so this is equal x1. X2 would equal negative 40 minus 52 here would be negative 92 over 8. And then this here would equal negative 23 over 2 here. And as you probably know, a dimension here cannot be negative, right? X2 here is probably the wrong solution, definitely the wrong solution, because I can't have a negative length here because I'm finding the dimensions of this print, right? So, or I'm finding the width of the frame, sorry, not the dimensions here. So in this case here, I can reject the solution and I can say x1 here is my solution here. So 3 over 2 is going to be the x value. And now what I can do is I can simply say that the x value here is simply 3 over 2, right? So all that work gave us x here would be 1.5 inches, right? So this here gives us the dimension of the frame. It's the width of the frame here is 1.5 inches. And as you can see, the width of the frame is 1.5 inches. So this solution here is correct. Good analysis here. That's number 7. That's a lot of work for number 7. Number 8 is asking what are the quotient identities for a trigonometric function. So 8 here, I want the quotient identities for trigonometric functions. So this here is just kind of like a table that we kind of need to know, right? So as you can see here, quotient identities here, they kind of give you a list, and I don't like how they didn't give you a diagram. So let me draw you a diagram real quick. So if I have a right angle triangle, again, trigonometric ratio refers to, I'm working with a right angle triangle. This is not a good right angle, sorry. All right. This is the best I'm going to do. Here's the right angle here. So I'm going to have some angle here, and I'm going to call this angle theta. So this is we use angle theta to denote an angle here. So at angle theta, we have this here would be, I'm going to say here, this is, this here, this is all, it's all in reference to angle theta, right? So for example, sine of theta would equal opposite over hypotenuse, right? So you can say this here is the opposite over the hypotenuse, and this one would have to be adjacent, right? So sine of theta here would be opposite over hypotenuse. You can think of the mnemonic as SOHCAHTOA to help you figure out trigonometric ratios. So sine is opposite over hypotenuse, cosine here is adjacent over hypotenuse, and tangent is opposite over adjacent, right? So I can write down those guys here. So sine, cosine of theta is adjacent over hypotenuse. Again, this A over H. And tangent of theta is opposite over the adjacent, right? Opposite over adjacent here. So we have these functions here, which is great, but we also care about R. We care about our functions in terms of the reciprocal functions, right? We care about these guys here. So we also care about, so we care about our cosecant x, right? So cosecant x or cosecant theta, we care about our secant theta and our cotangent theta, right? And this here is simply just the reciprocal trigonometric functions, right? So when we talk about this reciprocal, we can think of this as, it's simply just these guys flipped, right? So we can say that this here is simply just h over O. This here would now be h over A, and this here would be A over O, right? Where A here is this this adjacent, O here is the opposite, and hypotenuse here is the hypotenuse of the triangle. So this here is, again, these guys are my primary trig ratios, trig, and this here is the reciprocal trig here as well. So this here, again, because I know cosecant equals 1 over sine theta, secant is 1 over cosine theta, and this here is 1 over tangent theta. Or sorry, not 1 over cotangent theta, 1 over tangent theta. So this here is my solution for the number, this here was number 7, I believe, number 8 here. So this here is going to determine that, and then step 3 is saying they're basically two quotient identities, right? So quotient identities just means the relationship between tangent, right? So we know a tangent here equals sine over cosine, and that's going to be our first kind of quotient identity for this guy here. So tangent theta equals sine theta over cosine theta, and you can also, by definition, cotangent theta is simply just cosine theta over sine theta here. And why this works is that because sine theta here is opposite over hypotenuse over adjacent over hypotenuse, the hypotenuse cancels out, so you get opposite over adjacent, right? Like we proved here. Same with this guy here. I have adjacent over hypotenuse over opposite over hypotenuse. Again, the hypotenuses cancel out. And again, I have adjacent over A over O, which is this guy here. So this is our trigonometric, our quotient identities for the trigonometric ratio, these two guys here. Let me box this in blue for you. So these are very, very important to kind of both memorize, but to kind of understand where they come from. So this here is correct. Again, I'm writing on a slant again, so I'm sorry about that, but this here is correct. So solution is correct. Good analysis here. I think I'm going to do one more problem. Might have enough time to do one more problem, but this here is actually quite a long problem because we're going to have to do the, it's basically another optimization problem. I don't know if we have time to do this, but maybe I'll start this problem for you. And again, they didn't really show their work, so that's unfortunate. But maybe I'll see if I can start this problem for you, and maybe leave it for you to do for the next stream here. So as the top and bottom margins of a poster are 4 centimeters and the side margins are 2 centimeters, if the area of the printed material on the poster is fixed at 50 centimeters, find the dimensions of the poster with the smallest area. Check the value obtained is indeed a minimum here. So I didn't really get a diagram. So I'm going to assume that this is a rectangle. The poster is probably a rectangle here. And the top and bottom margins are each 4 centimeters. And the side margins are 2 centimeters. So I'm going to look at the solution here. It says assume the length and the width of the poster to be L and the height to be H. So they're assuming that, okay, the area can be described as something. We have to set the derivative to 0 to minimize it. Okay, that's good. But they didn't really show their work, right? So I think this is in 3 dimensions because it's saying length, width, and height. So again, it's much harder to kind of grab a diagram for this guy here. And they didn't really show their work, so I can't really verify if the solution here is correct. But what we're gonna have to do is basically figure out the kind of the height here as well. So I guess this is in 3 dimensions, I'm assuming. If you have something like this. So it's kind of in 3 dimensions here. So again, you have the length, the width, and the height here. And it's saying top and bottom are 4 centimeters and the sides are 2 here. So I guess the top and the bottom are 4. So I guess the length is 4. So I'm going to say this here is the length, this here's the width, and this here's the height. Or sorry, this here's the height, length, and width. And then it says the area is, I also don't know what this is. Is the area 50 centimeters? I don't know. Is that squared or cubed? I'm not sure. So I actually don't even know what the dimensions are in this question here. So again, I don't know what this two apostrophes here mean. It could be squared or it could be cubed. I'm thinking it's a squared term, so I don't think there's actually a height here. So I'm thinking this is actually in 2 dimensions and not in 3 dimensions. So I don't think that their solution here is correct, because they're giving us in 3 dimensions here when I think it's in a rectangle. And this is purely just, I haven't done any math yet. This is purely just observations, right? So, because again, I don't have time to like finish this problem here. So I'm assuming, let me see if I can find some sort of diagram for us to kind of look at, so it's a bit easier to kind of visualize here. So let me see if we can figure this out. So top and bottom margins of a poster are 4 centimeters, and the side margins are 4 centimeters here. And I think this is a square term here. So it's 50 centimeters squared. Find the poster here. So basically what we're saying here is we have here, this is X and Y, right? This here would be X and Y. And we're finding the area of a poster. Our area of a poster has to equal X here times X minus, I think I have 2 things actually, so give me a second. I think I have a margin here. So I think I have a rectangle within a rectangle. I think this makes a lot more sense here. Again, it's a lot easier with a diagram here. So this is 4. The top and bottom are measured in 4, right? So again, I'm guessing this here is 4. The margins here are 4. Oh, sorry. This here is 4. This here is also 4, and the side margins are 2, right? So this here is 2. This here is 2, right? So basically we can basically find the area of this guy here is as, well, area, we know it's length times width, right? So if I know that this here is length and this here is width, or this here is X and this here is Y, I can say that basically I have X here, which is simply, X here would be, let's see, some sort of X minus 2 times 2 times 4, right? Or 2 times, not 2 times 4, but 2 times 2, right? So 2 times 2 here. Because again, I have 2 here, I have a 2 here, and a 2 here, right? So 2 times 2 times Y minus 2 times 4, right? So I have something like this as my area. So this here, and this here would equal 50, right? So this entire equation equals 50 here. So I have, this is X minus 4 times Y minus 8 here. And I can basically, what I can do is rearrange for one variable and solve for again I have to rearrange for one variable and solve for the perimeter, because again I'm maximizing I'm minimizing the area again. So this here is the area of the entire frame here that I'm looking at. So again, I'm going to isolate for one of my variables here. I can basically use distributive property. I can say X times Y. I have minus 8X minus 4Y plus 32. And then what I can do now is that I can isolate for my Y value. And this would equal, let's see, 32 moved to the other side is 18, xy minus 8x minus 4y. And then I'm looking at, I can basically move the x's to the left side. So I have 18 minus 8x equals xy minus 4y. And then what I can do then now is 18 minus 8x equals, I can factor out y here to get x minus 4. Then y would simply be 18 minus 8x over x minus 4, right? 18 over x minus 4. So basically, once you get this problem here, you basically have to write another equation to figure out the area of the poster. So just the poster inside. So you have x times y here, and you would sub in your y value, find the derivative, set it to 0, and then solve for the one of the dimensions here. So maybe I'll pick up with this question. Maybe I'll redo this question for the next stream here because we've run out of time. But again, this solution here is incorrect. So maybe I'll save this solution and we can do this problem together for the next stream. So again, thank you so much for watching. If you like my videos, definitely look at youtube.com/OneClass, and we can figure out this. We can work on these solutions together. And what we can do, again, thank you so much for watching. Love the comments in the chat. Very, very encouraging as well. Again, my name is Joey. Again, I stream from Monday to Friday. Again, Monday, Wednesdays, and Fridays are math, and then Tuesdays and Thursdays are indeed chemistry. So you can catch me there, and I'll be there to kind of help you out with any questions you have. Again, thank you so much for watching. Stay safe, stay healthy, and have a great day. Take care.